Hello. In this video we will see the operation of pixels and their organization in an LCD screen. The display of an image is a complex process involving several electronic components. We will start with a reminder of some definitions concerning the characteristics of an LCD screen. When buying a television, the first thing we look at is its exterior appearance and first the width of the screen, L, its height, H, and its diagonal, D. Then, we must ask about the number of pixels it contains. LCD screens contain thousands or millions of pixels. To know the exact quantity of these pixels, we must see what is called the display resolution. This display resolution expresses the number of pixels it contains. It is calculated by multiplying the number of pixels contained on the width of the screen by the number of pixels on the height. Example: with a screen having 3,840 pixels on its width and 2,160 pixels on its height, the total number will be 8,294,400 pixels. This corresponds to a screen called 4K. This number of pixels will vary with the display resolution of the screen. We see on this table the different values of display resolution depending on the model. Compared to a 4K screen, an 8K screen contains 4 times more pixels. Two screens can have the same size, but what will differentiate them is the number of pixels that each will contain. At equal size, the higher the number of pixels, the better the shades of the lights and colors will be, and we will see more details. Conversely, what happens with two screens which do not have the same size but which each contain the same number of pixels? Here, on the larger screen, the pixels will be more widely spaced. On the other hand, on the smaller screen, the distance between the pixels will be smaller. To express this characteristic, we will use the term of pixel density. The pixel density is calculated using the inch as unit of measurement. An inch is equivalent to 2.54 centimeters, which is the average length of the second phalanx of the thumb. To know the resolution of a 16:9 format screen, you need to know the width of the screen, L, the height, H, the diagonal, D, and the display resolution, X pixels across the width, and Y the number of pixels on the height. We introduce all these values into a somewhat complex mathematical formula that will determine the value of the pixel density. The result of the pixel density is denoted by the abbreviation PPI, which stands for pixel per inch. In this example, the 42-inch screen has a resolution value at 104 pixels per inch. That is much higher than the 65-inch screen. The difference comes from the fact that to put so many pixels on a smaller surface, you have to bring them as close as possible. Now technological developments allow 22-inch screens to be manufactured in 4K. The advantage of having a maximum of pixels is particularly useful for large screens that can display as much detail as possible. With an insufficient number of pixels over a large area, the image will look pixelated. This table shows various characteristics of 16:9 format televisions. For each television set is noted in the first column the display resolution, which corresponds to the quantity of pixels it contains. On the second column, we find the standard used. For example, on the first line, a screen of 720 by 480 pixels corresponds to the DVD standard. On the third column is noted the name of the display resolution. To describe it, we use the second number, which represents the number of pixels on the height of the screen and to which has been added the letter P, the exact meaning of which will be detailed in a moment. The last column represents the various trade names for these televisions. It is more telling for ordinary people to say a 4K TV than a UHD TV1 or 2160p TV. We will now see what corresponds to the letter P in lowercase, following the digit of the number of pixels on the height of the screen. There are two display technologies of the lines in a screen. The so-called P mode stands for progressive scan. The lines are displayed one by one. The other mode is an old technology called interlaced. This technique was used in cathode ray tube televisions. The screen is scanned by an electron beam. The image is split into two parts, an odd frame image and an even frame image. The quality is better with the P mode, which is the progressive scan. The drawback of the interlaced mode was that it sometimes gave the appearance of a duplicated image. Now, We're going to tackle the technical part, to see how this phenomenal quantity of pixels works. On this screen taken as an example and to simplify things, this screen contains very few pixels. If we do the calculation 6 by 7 gives us a display resolution with 42 pixels. But we know that each pixel is represented by 3 sub-pixels. Each sub-pixel is dedicated to the display of the red color shades, another for the green and a third for the blue. In total, this screen has 42 pixels by 3, which gives a total of 126 sub-pixels. The sub-pixel is an electronic component made of a transistor type TFT, which is the acronym of thin film transistor. It is represented as a MOSFET. There is a gate, a source and a drain. In addition to this transistor, there is the liquid crystal which behaves electrically like a capacitor. At its sides is put a real capacitor called storage capacitor. The latter was added because the liquid crystal does not hold the charge properly, hence the idea of adding a capacitor in parallel to maintain the display of the liquid crystal until the arrival of the next image scan. If there was no storage capacity, the liquid crystal would have lost its charge and therefore its luminosity, while a new electrical impulse was being sent to it. The power supply of each sub-pixel is done in the following way. All the gates placed on the same line will receive the same power supply, either VGH or VGL. However, each source will receive a different voltage. This voltage corresponds to the analog translation of the digital data of the color of each sub-pixel. This concept will be discussed in more detail in a future video. The storage capacitor and the drain of all the TFT transistors composing the screen are connected to the same conductive track, which is the VCOM. To control all these circuits, there are electronic components called drivers.